Let's start with our name and the date. Today's lesson is lesson 4.1, representing linear non-proportional relationships. And this is pages 89 to 94 in your book. We have an essential question. How can you use tables, graphs, and equations to represent linear non-proportional situations? In your book, on page 89, we have example 1. The equation y equals 3x plus 2 gives the total charge y for bowling X games at Baxter Bowling Lanes based on the prices shown. Make a table of values for this situation. So we are going to realize that we have the equation y equals 3x plus 2, where we're told that y is the total charge or the total cost, x is the number of games, that are played at the bowling alley, and we need to make a table. And they actually started us out with our values for x. And remember, that is our domain. And if we use our calculator, we can do this a couple of ways. One way would be to substitute the value for x into the equation. So 3 times 1 plus 2. And we get 5 for that one. And we can do that for everyone. The other way is to go y equals, and we want to put that equation in there. So we're going to do 3x plus 2. Now, I could graph it, but I don't want to graph it right now. What I want is I want to come up with the table. And if you look right above graph on your calculator, there's a word that matches the color of your second button. So if you do second and then graph, you get the table. Looks like I need to do something with my calculator. One moment, please. Yes. That looks better. Okay, so we have 1 is 5. And if we keep going down, 2 is then 8. 3 would be 11. And 4 would be 14. And that takes care of example 1. Now let's move to example 2. Sorry, my notes got messed up. Example 2. This is the entrance fee for the Mountain World theme park is $20. Visitors purchase additional $2 tickets for rides, games, and food. The equation y equals 2x plus 20 gives the total cost y to visit the park, including purchasing x tickets. So we want to complete the table. Looks like we also need to graph it, and a few other things. So here we go. Again, we were told that our equation is y equals 2x plus 20, where y is the total cost, x is the number of tickets purchased, and we start by making a table. When you make tables, it's sometimes wise to identify what the x is standing for and what the y is standing for. That helps you keep it straight and you don't get confused. Well, if we purchase 0 tickets, 2 times 0 is 0, so our cost is $20. 2 times 2 is 4, plus 20 is 24. 4 times 2 is 8, plus 20 is 28. Again, we could have used our calculator here, but we're just multiplying by 2. That's 12, plus 20 is 32. And 8 times 2 is 16, plus 20 is 36. Then we need to plot our ordered pairs. So I'm going to sketch a graph here. My x is the number of tickets. And notice that when I do my graphs, I'm also always labeling what they are. My y is the total cost to visit the park. And I'm going to do my scale. And I'm going to put that these are by 2s here. And my cost, I'm going to make that worth 8, which means that's 16, 24, 32. And I'm going to start plotting those points. So I have 0, which by the way is right there, is $20. Well, that's going to be halfway between 16 and 24, so there's my point. For 2 tickets, then we spend $24. 4 tickets is 28. 6 tickets is 32. And 8 tickets is 36. And if I were to look at that, it looks like they're in a line, so I'm presupposing that I could draw a line through those, and I could do some predictions later, such as 10 tickets is going to cost me, that would be $40. We might want to look at, is our rate of change constant between each point and the next? And I could do, let's see, 4 would be 28 minus 24. Again, that's 4 minus 2. 4 over 2, which is 2. Or I could choose 8, and I can pull them from here. 36 minus 32 over 8 minus 6. Again, that's 4 over 2, or 2. So my rate of change is constant. Because that happens all the time. Now, the thing is, this is not going to be a proportional relationship because we're not going through 0, 0. So this is a non-proportional relationship because our starting cost is $20 when we have 0 tickets. And we have one more example that I want to do. First of all, talk about a vocabulary term, linear equation. Linear equation is an equation whose solutions form ordered pairs x comma y that form a line when graphed. That's one reason why we call it linear. Linear means it forms a line. And the form of the equation is y equals mx plus b. Example 3. I think is where we are. And this one again is in your book. This one is on page 91. The diameter of a Douglas fir tree is currently 10 inches when measured at chest height. Over the next 50 years, the diameter is expected to increase by an average growth rate of 2/5 inches per year. The equation y equals 2/5 x plus 10 gives y the diameter of the tree in inches after x years. Draw a graph, describe the relationship. So we need to first of all make a table. We were told that our equation is y equals 2/5 x plus 10, where y is the diameter of the tree, x is the number of years, and we're going to have to draw a graph and describe the relationship, but I would start by making a table. So x is the years, y is the diameter, and again at this point I would probably pull out my calculator and not do this by hand, And the easiest way to do this again is to go into y equals, okay, looking for a place where you can see this, and I'm going to put in that equation. Remember, fractions go inside parentheses. We actually have an X button. And if I just want the table, I can go second graph. And 0 is 10, which is how we started. And I want 10 years. But if you notice here, it goes by ones. I can either just scroll down because it continues, and then there's 10, which is 14. And that is one way to keep doing this. 20 is 18. 30 is 22. And all the way to 50. Oops. But that's okay because I can just go up and there's 50. Okay. So we also needed to do a graph. Again, remember to label everything. Your X is the time in years. Y is the distance, or the diameter I should say, in inches. When I go to plot this, I'm going to use these points. So 0, 10 is my starting point. Then I need 10, 14. Remember, this is 8, that's 16, so that would be 4, that's 12. So the 10 went here between 8 and 12. 14 goes between 12 and 16. 20 is 18. Again, it'll be in the middle. 30 is 22. And I didn't go out far enough to do 50, but that's okay. And these look to be in a line. So it's linear. Again, it's not going to be proportional because it doesn't go through 0, 0. Another way, remember, to figure out proportional is to do your k equals y over x. And we can do that by doing 10 over 0, which is actually undefined. We cannot divide by 0. Then I can do 18 over 20, which is 9/10, so that's 0.9. Then I can do 22 over 30, which I can't figure that one in my head, so I'm going to come to my calculator. 22 divided by 30, that's 0.73 with a repeating bar. You've got 3 right there. They're not the same, they're not constant, it's not proportional. And at this point, it is time to talk about your quick check. And I'm going to put it right here. There is the your turns. And you have number 1 on page 89, and number 3 on page 91. On page 89, there's this one. And then on page 91, you have this one where you have to do the table and the graph like we just did. So refer back to your notes.